Okay, and welcome back, students taking the Math for Business and Finance and Math Applications. And we're continuing on with the Chapter 10 word problems, odd number problems. And that problem 23 took up that entire video, so let's move on to 25 here. Okay. Joanne and Ed Greenwood built a new barn with an attached arena. To finance the loan, they paid $1,307 interest on $45,000 is the principal at 4%. That's the rate. What was the time using exact interest and round up to the nearest day? So remember, exact interest is 365 days. And since we know that the formula is interest is equal to principal times rate times time, again, if we want to solve for time, we set the time equal to, and I just put the interest in the numerator and whatever's left over, principal times rate, in the denominator. I don't have to memorize the formula, okay, by doing it that way. So now let's fill in the data, okay. So I have interest of 1307, and my principal is 45,000 times my rate of 4%. And that's going to equal, all right, so let's see here. Let's see, 45,000 times 0.04 is, oops, not 45,000 times 0.04, right? So 45,000, get my pen here, times 0.4, I mean 4% is 1,800, okay? And if I take 1307 and I divide that by 1,800, I end up with, so that's 1307 over 1,800, and that ends up being 0.7261111. Okay. Now we're using exact interest, which is 365 days. So I am going to see, I had 4, right? Let me erase that to make it look a little neater here. That's 1, 2, 3, 4. This is what my calculator is showing right at the moment, at this moment in time. And I'm going to multiply that by 365 days. Okay, so times 365, which means I end up with 265.03. Okay, and we're going to round that to the nearest day. So, 0.03 we're going to round down. I'm sorry, round up, all right, because it's greater than a full day. So we end up with 266 days. Okay, and that's how you do that problem. All right, let's see here. 10-27. All right, and because we're working on 10-27, and it says Steve met Jennifer in problem 1026. Let's do 1026 and then come back to 1027. Right. So on September 14, Jennifer Rick went to Park Bank to borrow $2,500. That's the principal at 11.75%. That's the rate. Jennifer plans to repay the loan on January 27th. So this is the beginning day and this is the ending day. So if I draw a timeline, I have 9/14 and she's going to pay it off on 1/27. And remember, this is, we're going through the end of a year. Okay, so that's 1/1 right there. Okay. Assumed loan is ordinary interest, so that's 360 days is what we're going to be working with. What interest will Jennifer owe on January 27th? And what total amount Jennifer must repay at maturity? So this is basically just like any of the other ones that we were doing, where our interest is equal to principal times rate times time. And then in order to calculate our interest, and once we know our interest, we're going to figure out the maturity value, which is the principal plus that interest that we figured out. Okay, so we have $2,500 as principal times 11.75% as our rate. And remember, for that rate, 11.75%, we move the decimal place over 2. So we're going to use 0.1175 as the decimal format for that 11.75%. Okay, times, now we know it's ordinary interest, so that's over 360. But we have to figure out how many days between September 14th and January 27th. So we bounce up to our Julian calendar, and we start out with September 14th. So here's September, here's the 14th, that's 265, and I'm sorry, 257. And we're going through the end of the year, so that's 365 less the 257. That's 108 days from September 14th to the end of the year. And since we're crossing the years, now we're in January, and she's paying it back on January 27th. So that's 27 more days, so we have to add in the 27. So we end up with 135 days is the number of days that she's borrowing that money. Okay, so let's go back down to our problem and put in that 135 days in the numerator, and we do the math. Okay, so we have 2,500 times 0.1175 times 135, and that gives me 39,656.25 all over 360. And when we divide by 360, we end up with interest of 110.156. Well, I'm rounding up, right, because of the 6. So $110.16 is my interest. And then, of course, to get my maturity value, I'm going to add my principal, which is $2,500, plus my interest of $110.16, and I end up with a maturity value of $2,610.16. Okay, that's my maturity value. Okay, so now problem 10-27. It just dawned on me. Let me quickly look. Give me 1 second here. Yeah, just as an FYI, if you went back to the word problems for 10-16 and 10-17, this is the same exact line of thought, okay? Those two problems are identical to these problems. So if you need a little bit extra, understanding, go revisit those particular problems. Because 10-26 is talking about ordinary interest over here, okay? And 10-27 is, suggested she consider the loan on exact interest, which is 365 days. So the only difference between the two is we're going to do the same calculation, but instead of using 360 days here, we're going to use 365. So I have the $2,500 times 0.1175, 11.75% interest, times 135 days over 365. So when we do the math for that, 2,500 times 0.1175 times 135 gives me 39,000. 656.25. Same number as up here. Okay. And we're dividing by 365. Divided by 365. And I end up with 108,647. So I'm going to round that to $108.65 of interest. The maturity value would be 2,500 plus 108.65. Of course, that's 2608.65. And if I want to know what the difference in the savings are, I would take my interest of 110.16 and subtract the 108.65 and subtract 108.65, and that means I would save $1.51 in interest by using one method versus the other. Okay, by using the exact interest. Okay. All right, so we're at 11 minutes, and I'm going to stop here and pick up with problem number 29 in the next video.